Let's now look at a few properties of judgment aggregation methods. These really are just the analogs of the properties we already studied when we looked at different voting methods and Arrow's theorem. We're going to start with anonymity. So anonymity really means the same thing it did earlier, namely the output under a judgment aggregation function doesn't depend on the order in which the individual judgment sets appear. So for example, if there are just three voters, f of A1, A2, A3 must be equal to f of, let's say, A3, A1, A2. So the order of the judgment sets or the names of the voters doesn't matter to our group aggregation function. Next, unanimity. Unanimity means for any profile, if everybody accepts P, so everybody judges P to be true, then society must judge P to be true. So the group aggregation set must include P. So again, it's essentially the same notion we've been studying, just applied to this new framework. Monotonicity also will be familiar. Given any P, given any proposition in our agenda, and any profile whatsoever, suppose that everybody keeps their judgment sets the same except for voter I. And voter I did not have P in his judgment set under the first profile, but in the second profile, P is added, which necessarily means the negation of P was removed, since we're assuming the judgment sets are complete. So intuitively, what it means is that voter I at first judged P to be false, and then we move to a new profile where voter I now judges P to be true. All the other voters keeps their judgment sets exactly the same. If that's the case, and if P was accepted under the original profile, then it must also be accepted under the new profile. And why is that? Well, intuitively, it's because there's more support for P. There's one voter who added his or her support to P, who now accepts P, who maybe didn't accept P before. And if before this voter decided to accept P, P was already accepted by the group, now even more people accept P. So P should be accepted under the new profile. So that's monotonicity. Roughly the same idea that we're already quite familiar with. Next, we're going to look at independence of irrelevant alternatives, or the analog of independence of irrelevant alternatives. This is what's called systematicity. So systematicity says for any propositions in the agenda, any two propositions in the agenda, P and Q, and all judgment profiles, A1 up to AN and A1 star up to AN star. If it's the case that for all I, P is accepted by the same voters as Q is accepted under A star. So we have the same profile of acceptance for P as we do for Q. So both P and Q have exactly the same profile of acceptance, where profile of acceptance is really just the voters that accept P, the set of voters that accept P. If that's the case, then our judgment aggregation function has to accept P under A1 up to AN, if and only if it accepts Q under A1 star up to AN star. Note, this really is two assumptions built into one. The first is an independence assumption. So independence means given any proposition P, whether or not the group accepts P, whether or not the group judgment set accepts P, depends only on P and not formulas that are irrelevant to P. The second is neutrality. The second aspect is neutrality, where the names of the propositions doesn't actually matter. So if the profile of acceptance for P is exactly the same as the profile of acceptance for Q, then the group decision method must judge P and Q in exactly the same way. If it accepts P, then under A1 star up to AN star, F has to accept Q. If it doesn't accept P, then F can't accept Q under A1 star up to AN star. We can drop the neutrality assumption and just define the analog of independence of irrelevant alternatives. This just says for any proposition P, if the profile of acceptance for P under one profile is exactly the same as the profile of acceptance for P under the other profile, then P is accepted by the group if and only if it's accepted by the group under the second profile. So we can pull apart the independence and neutrality assumption if needed. Finally, we have the non-dictatorship assumption. This just says there is no voter I such that for any profile A1 up to AN, the output of the group aggregation method is exactly voter I's aggregation set. That's non-dictatorship. Here's a baseline result. This is the first impossibility theorem in the judgment aggregation framework. This is by Christian List and Philip Pettit. It says that if our agenda is a subset of A, B, and A and B, so our agenda contains at least A and its negation, B and its negation, and A and B and its negation. So that's what this means. This notation is a bit misleading because actually X has to contain A, not A, B, not B, A and B, and not A and B. A very simple agenda. So the propositions on the table are just A, B, and the conjunction of A and B. Then there exists no aggregation rule that satisfies universal domain. So the domain of our aggregation function is going to be the set of all profiles of consistent and complete judgment sets. Collective rationality, so the group aggregation set or the group judgment set is complete and consistent. Systematicity, so that's really the independence and neutrality assumption wrapped into one. And anonymity. So this is an impossibility result that's an analog to Arrow's impossibility theorem.